Alright, so we are doing our second day of interpreting key features of graphs and tables. Alright, learning goals for this. I can describe the relationship between two different values given a graph or a table, and answer questions and explain my reasoning for answers based on information given in a graph. Alright, let's take a look at our first example, which is actually similar to an example from the previous video, but we want to make sure you understand how to do this. So we want to match each graph with its related table and explain our answers. So if we look, what we want to do is we want to say, okay, so each step of the way this is decreasing. So we look at our graphs first. Each step of the way it's increasing here. And then here we are increasing, all right, and then decreasing. So we're looking for something, so let's start with the first one. We're going decreasing, decreasing, decreasing. And the speed decreases as time goes on. That's our explanation, so let's look for that. So as time is increasing in all of these, and here we have our speed increasing each step. Here we have our speed increasing, then decreasing, and then here we have our speed decreasing each step. So this one here, match is that one. So again, if we label this A, B, C, D, E, and F, A would go with E. You know, you can't really see there. Oh, no, A would go with F. Sorry, no, I had that right the first time. A would go with F because it's constantly decreasing. So we've matched it and we've given our explanation. Here we have it constantly increasing, so these two go together. So B and D, and speed is continually increasing, which leaves, and we want to make sure it matches, increasing, increasing, decreasing, decreasing, which is going on there. So speed increases and then it decreases. So that's all you need for an explanation. And as far as matching the graphs, I strongly suggest doing this like here and here, you know, with each one, just so you can kind of see. Alright, so second and last example for this particular target, we want to answer each question below based on this graph over here. So explain why we agree or disagree. The velocity is always increasing. Well, so velocity is this. Is it always increasing? Well, it's increasing here, but here it's not doing anything, okay? There's zero rate of change. So just, we can even stop right there, and we can say it decreases from E to F. So here's a case where it's decreasing, okay? It's constant from B to C and from D to E. Okay, here, increasing. Here, it's increasing. Here, it's constant. And here, it's increasing. So again, you can go through your graph and do this. Now, if it was always increasing, we'd only have plus signs here. So it decreases from E to F, constant from B to C, D to E, and from F to G. So we don't even need to say where it's increasing. We just need to give examples where it's not. Okay, explain why we agree or disagree. The domain of the velocity and time graph is all real numbers. Remember, all real numbers, okay, includes negative numbers. Okay, and obviously here we are only looking at positive numbers because time can't be negative and velocity also can't be negative. So velocity cannot be negative, so the values can only be positive. You only need to say one, so we say velocity. But if you put time and velocity cannot be negative, then that would be acceptable too. But this is what's important, that the values can only be positive. All right, and then between what two labeled points is the most rapid change in speed? So this is key right here, rapid. It doesn't necessarily say the greatest because positive numbers would be bigger than obviously the negative numbers. And we can't have a negative rate of change. That would be where velocity was decreasing. So we basically have to go through, we can eliminate this and this and this because we know that the rate of change there is 0. So we basically have A to B, C to D, and E to F, and G to H. We need to go through and apply that rate of change formula to each one. So A to B, which is rise over run. So basically going up or down and then right. The other thing you can do is you can use your, here, let me clear all this off so we can have a little bit more room. So in this case, like a to b is 20 over 2, and what we do is we say, okay, so if I take this and I, basically square it off, I went from 0 to 20, so that's where my rise is. It went up 20. Rise will be positive if you're going up. And then I went from here to here, which is 2. So I can just say 20 over 2, which is 10. C to D, okay, I started at 20, and I went up to 40. Okay, 40 minus 20, let me go back. 40 minus 20 is 20, so that's where I got this. That's 40 minus 20. And this was from 4 to 5, which is just 1. So this space here is just 1. And again, that goes on the bottom, don't forget. So we have a rate of change of 20. From E to F, so from here to here, now we have a decrease. And I was at 40, and I went back down to 20. So I have a decrease, so it's negative. Okay, negative is because decrease of 20, and then again we have a space of 2. So negative 20 divided by 2, which is negative 10. And then finally, G to H. So for G, we went from 20 to 30, and we went up, so that's a positive 10. And then we went right 1, so that would be 10 over 1, so that's 10. So if we look, C to D had its greatest rate of change, at the most rapid rate of change, and we showed all our work. Now keep in mind, even if this was negative 20, this would still be the most rapid rate of change, because it's the, how far is it changing up or down. So it could be negative too, and that's fine. It's just if we took the absolute value of all of these, which one would be the greatest? That's the best way to describe it. All right, and that's it for this one. We are more than halfway through the key concept now. So if you have any questions, let me know, and we will be going over this more in class.